Hello guys, in this video we'll learn about a very important phenomenon of light called as reflection. But before we understand reflection of light, let us first understand what is light. Light comprises of electric and magnetic field which are perpendicular to each other. Thus light falls under the category of electromagnetic waves. There are many other elements of electromagnetic spectrum such as gamma ray, X-ray, ultraviolet ray, infrared ray, microwave, radio wave, with visible light being a small part of it. Well, that sounds too complicated, right? Let's park this aside for the time being and understand light in a simple manner. Light can be simply understood as an agent that gives us sight. It is something very important that makes us see things around us. It's everywhere around us, be it coming from a sun or a bulb at your home. Mostly we call light as a ray as it originates from a source and travels in the form of straight lines. Light is also referred as a wave for its characteristic of interference and as a particle for its characteristic of transmitting energy. Be it a ray, a wave, or a particle, they are simply different models of the same light that helps us understand various phenomena. Light as a ray has its application in telescopes, light as a wave helps us understand interference, and light as a particle can tell us more about the photoelectric effect. The wave and particle nature of light will be studied in subsequent lectures. For the time being, let's explore light as a ray. What happens when a ray of light strikes an object, let's say a surface? It can either reflect or absorb or transmit. For example, let's say if the surface is wood, then the light will get absorbed. If it's a glass, then the light will get transmitted. And if it's a mirror, it will get reflected. Let's park the transmission and absorption phenomena for the time being. In this session, we will specifically focus on reflections. Did you know, if light stops exhibiting the phenomena of reflection, we would be as good as blind, which means we'll not be able to see anything around us. Want to understand more as to why can this happen? Let us first understand what enables us to see objects around us. What you might have studied in past is the light originates from the eye and it travels to bounce off the object to again reach the eye, and thus we end up seeing the object. Well, there is something wrong here. Are you able to figure out what? Okay, had this been correct, you would have been able to see objects in dark where there is no light. But are you able to do that? No, a big no. We just discussed this. The problem is that to see an object, you need a light source, which is certainly not your eyes. Hence, the source of light is missing in this case. Well, this is a very common pitfall and I want you guys to avoid this. So how do we actually see things? The correct setup would comprise of three things: a source of light, an object, and a receiver, which in this case is our eye. Now, the light from the source will fall on the object and reflect to reach the eye, and this signal is processed by our brain and we are able to see what we see. Now that is called sight. Let us dive a little deeper into reflection. But before we start doing that, I want you guys to remember this. Light always takes the quickest path. Let us understand what do I mean by the quickest path. In the given case, let's assume that light can travel via the given two paths. But given the nature of light, it will always choose to travel in the quickest possible way, hence the straight line. Now we will learn a very important law of light ray called as the law of reflection. Law of reflection states that the angle of the incident light ray from the normal is equal to the angle of the reflected light ray from the normal. To understand this better, let's take a reflective surface and a light traveling from source A that reflects at B and reaches the receiver at C. Let's draw a normal at B with I being the angle of incidence made by the incident ray with the normal and R being the angle of reflection that the reflected ray makes with the normal. Now as we know that light always takes the quickest path, our aim here is to make AB plus BC as short as possible. So how do we do that? Well, I want you guys to visualize this in a different way. We will reflect the point C along the reflecting surface to obtain C dash. Now, AB plus BC can be rewritten as AB plus BC dash because BC and BC dash are equal. Now, for AB plus BC dash to be as short as possible, A, B, C dash have to be collinear. That is, they should lie on the same line. Now to reach point C dash, light being smart enough will take the quickest path and will travel in a straight line. So this diagram will look something like this. Based on our earlier finding, the diagram can be redrawn as the following. Let the 2 points on the reflecting surface be D and E. Join AD and join CE. It can be seen that B lies on the midpoint of the line DE. Now using alternate angles equality property, we can say that angle DAB is equal to I, which is the incident angle, and angle BCE is equal to R, which is the reflected angle. Now take triangle ABD and triangle CEB. Are you able to see that they are congruent? Let me tell you how. Segment BD is equal to segment BE. Why? Since B is the midpoint. Angle ADB is equal to angle CED. Why? Because both are 90-degree angle. And segment AD is equal to segment CE. So based on the following information, can we not say that triangle ABD and triangle CEB are congruent by side angle side test? Now since the triangles are congruent, the corresponding angles of both triangles should also be equal. That is, angle DAB should be equal to angle ECB, which means angle I, which is the incident angle, is equal to angle R, which is the reflected angle. We have just proved a very important law in physics, which was the law of reflection. What was that? The law of reflection stated that the angle of incident light ray I from the normal is equal to the angle of reflected light ray R from the normal. Hence I equal to R. Hence proved. I hope you enjoyed this video. I'll see you with